let's talk about how we can represent precipitation reactions. We could write just a typical balanced chemical equation. Remember, a precipitation reaction is a double displacement, so we swap partners, cations with anions. Let's do our little trick of writing the formulas in the margins. So this is lead 2, so it's 2 plus. Nitrate is 1 minus. Sodium is 1 plus. And iodine is 1 minus. We have them swap partners, so the sodium will go with the nitrate and the lead 2 will go with the iodide. So Na plus and NO3 minus becomes just NaNO3. And lead 2 and I minus, we need 2 iodines to balance 1 lead, so that will be PbI2. Now we need to balance the equation. We've got 1 lead, 2 nitrates, 1 nitrate, so let's put a 2 there. That gives us 2 nitrates and 2 sodiums, so we need to put a 2 there. That gives us 2 sodiums and 2 iodines, which balances with the iodine on this side. So our equation is balanced. Now let's talk about state symbols. Remember, if something is a strong electrolyte, it's going to dissociate in solution and it gets an AQ, which means it is dissolved in water. And sodium nitrate is soluble in water, so it gets an AQ. Remember, anything that contains sodium and nitrate is soluble with no exceptions. Things that contain iodide is usually soluble, except when paired with lead 2 is one of the exceptions. So lead 2 iodide will be insoluble in water, so it gets a state symbol S. And what we'd see with our eyes is the formation of a precipitate. Remember, if things are soluble, they have an AQ and they will stay in solution. If something is insoluble, they get the state symbol S, and that indicates that it is a precipitate. And in fact, this is a beautiful yellow precipitate. Okay, so we've balanced our equation and we've predicted that we will get a precipitate. So that's one way of representing that reaction. Another way to represent that reaction is to write a complete ionic equation. And by the way this is written, we call that a molecular equation. Okay, so that's the molecular equation. Okay, so now let's go ahead and write the complete ionic equation. And the complete ionic equation involves splitting strong electrolytes into ions. So for now, in Chemistry 1405, you can assume that if it's an AQ, it's a strong electrolyte. Okay, there are some weak acids that don't completely split into ions in solution, but for now, you don't need to worry about that. If you see an AQ, you can assume that it is a strong electrolyte. So let's go ahead and split those aqueous solutions into ions. Lead 2 nitrate will form Pb2 plus and 2 NO3 minus. Sodium iodide, we've got 2 of them, will form 2 Na pluses and 2 I minuses. 2 sodium nitrates will form 2 Na pluses and 2 NO3 minuses. And lead 2 iodide, remember, it precipitated out. So it's not dissociating into ions in solution. It is staying together as PbI2. I always run out of paper when I do a complete ionic. So we have PbI2, which is a solid. So anything that was still in solution stays on its own with an AQ. Anything that got together to precipitate out, we leave as a whole formula unit. Okay, and it's a solid. So actually anything with an S, an L, or a G, you're going to leave together as a formula. Anything with an AQ, you're going to split into ions. So you'll notice that we have nitrate on its own on the left-hand side and on the right-hand side. Sodium is on its own on the left-hand side and on the right-hand side. And we call that, when we have something like that, we call those spectator ions. Okay, because they're not taking part in the reaction. They're just spectators. Okay, they're vehicles for getting the other two things together. Because really, what's going on in that reaction? Pb2 plus and 2I minus is getting together to form PbI2. So we can just go ahead and we can delete the spectator ions, and what we're left with is called the net ionic equation. And in this case, the net ionic equation will be Pb2 plus from here plus 2I minus getting together to form our precipitate, which was PbI2. Because that right there is really the business end of the reaction, right? Lead gets together with two iodides to form lead 2 iodide. And the other ions that are floating around in solution are really not taking part. They're just vehicles to get the lead and the I2 together. Okay, so molecular equation is when you write out the whole formula units. Complete ionic, you split the strong electrolytes into ions. You leave the solids, liquids, and gases as formula units. And then the net ionic, you delete the spectator ions and write what you're left with. Okay.